everyone. My name is Eirik Klokkerersund. Thanks for having me. It's always great to be back in Aberdeen. I have a new oversized topic today. I know Bjørn Inge also will talk about oversized as a theme later today. So why is there so much focus on oversized mooring equipment these days? In oil and gas, what we do day to day, I would say the answer is no. We don't have any problems with oversized mooring equipment. There is, of course, a lot of permanent mooring projects like FPSOs. We see the dimensions go up. So the main driver for the discussions we have had these years is, of course, floating wind. And here also Solstad is part of an alliance called Windstolo Alliance. We cooperate with Deep Ocean and Aker Solutions, where we bid on a lot of floating wind projects. And some years ago, 2, 3, 4 years ago, we saw chain dimensions all the way up to 220 millimeters. It looks like the operators now have realized that the floating fleet is built for maximum 165. So that's also reflected in a lot of mooring systems we see today, that they stop at 165. I want to start with a safety alert. This happened in 24 on one of our vessels in Solstad. On the picture to the left here, you can see our chain chutes. To the left, we see it's fully extended to reach the aft chain locker. And to the right, we see it's halfway hinged, so we have access to the center cable chain locker. This is a new design. I think we built it for two years ago or something. We're very happy with the system. We don't need to lift chain chutes offshore. They are quite heavy and quite long, and we don't like to have these lifts offshore, often in 2, 3, 4 meter HS. But this, during an operation autumn 24, we were running some chain off the chain lockers, and as you can see down to the right there, the chain locker opened and fell down to an anchor we can see just on the bottom right there. So we had personnel in the vicinity, and the consequence could have been fatal. Luckily, no personnel damage. So I think this one is very important to share. All vessel owners with chain chutes need to verify the chutes. The root cause for this incident, as you can see up to the right there, we have a securing bolt securing the chute in the upper position that was inserted upside down. So it fell out during all the vibrations and when we spooled this chain. So the corrective action, we have rebuilt the bolt, so it's only possible to take the insert from top to down. So I think this is the right forum to share this one, and we have shared this earlier on conferences also, but still valid. Yeah, so what is oversized chain? I will mostly focus on chain. All anchor handlers today are built with 76 to 165 winch capacity. Here we see what Visionay have produced over the years, and also Asian Star. So we see a lot of chain sizes above 165. Some of these has not been in the chain lockers, only deck lengths, but we know some of these also have been run over a cable lifter and into the lockers. We need to touch up on a little bit on the chain handling history. I believe this is one of the first winch packages delivered. 2 winch, cable lifters on the sides, and we got 4 tin cans in the deck that I believe is the chain lockers. I'm not sure if this wooden chute belongs to this vessel, but something I found in the woods the other day. So decades later, we are still running the chain on the same principle. This is our representative winch package today. triple winch waterfall. We have cable lifters on the center on this one. I will not start the discussion center cable lifters versus cable lifters on the side. I don't think I have enough time for that topic today. So 76 to 165, you probably get tired of me mentioning those two numbers. But this is 76 in 3D to the left and 165 in 3D to the right. And as you can see, we have the chain in a theoretical vertical position. That's a typically engineering mistake, and we know a lot of projects actually had problems with this because it will form an X when it comes over the stern roller. To the left, it's not a problem to secure the chain with 76, 84, 120. We have centering device that is built and can handle these loads. When we come to 165, we cannot use our centering device. They are too weak, and we need to go old school with using tuggers to be able to center the chain, and also the shark jaws are not often strong enough to be able to lift the chain when we get these dimensions. Oversized chain is above 165, but what I will show now is that we will have a lot of issues and problems with running chain, even for a vessel built for 165. So we have a quick fix for the chain, for the shark jaw. We can take one of these out and send them to Kongsberg, and they can send it back 2 weeks later, and it's suitable for 190 millimeter chain without compromising the MBM. Another option, a more expensive option, is to purchase new shark jaw packages. This is from a couple of vendors. They can be delivered now up to 220 millimeter. And they also have this, we don't need a centering device, they will self-center, so we don't have these problems with securing the big chain in the shark jaw. This is something we will look upon naturally. Our vessel is 10, 15, getting close to 20 years of age. So we actually have started to change out a lot of this equipment after all these years of operation. We move further forward in the 3D world. We can see a cable lifter. Someone call it a gypsy, cable wheel. A lot of names on this. And we see the difference on a 76 and a 165. So we get a much bigger diameter on a 165. Bigger the arm, bigger the moment, and we will get reduced capacity when we run bigger diameter chain. I don't think this will be a problem, especially in floating wind, where we talk about mooring line installation, where we take the chain to the field, unspool it, and lay it down on the seabed. But it's something to be aware of, that the capacity will go down when we install a bigger cable lifter. There's also been a development over the years for the cable lifters. To the left, we see the first generation, 150 millimeter hexagon, the red area. And I guess around 2005, 6, 7, it was standard with the middle one, 310 millimeter. So you get more surface and you get higher line pull on the cable lifters. There's also come a new cable lifter. I haven't seen that in action. It's supposed to have better geometry and more suitable for high tension operation. So we have a lot of vessels with a winch package able to run 165. But someone has built a vessel around it, and we see we have a lot of issues. I think these two pictures to the left are very illustrative. This is a 157 cable lifter, and if you see in the crane there on the bottom, we have to cut off the flange to be able to get it down the hatches to the winch to install it. We also see a lot of vessels are under-specced on crane capacity, not designed to lift the big cable lifters that we are supposed to install if needed. So those two are classics, crane capacity and hatches down to the winch. We also see here on the right side, this is 147 chain. And it gets, we need to do a lot of modifications just to be able to fit the chain. And we also need to reinforce below the chain table. This is a center cable lifter vessel. Usually we can cross-run the chain, so we only need one cable lifter to fill all the 6 chain lockers. But when we get up in these dimensions, we need 2 cable lifters since we are not able to cross-drive. So that is something we try to have focus on if we have a job we need chain on all lockers. I don't have my speaking notes, but I think there's a lot of missing focus on the chain handling system on the existing fleet today. I have divided it in 2. On the left side here, I call it a passive system, where we only have chain chutes directing the chain to the lockers. There's no hydraulic, electric pullers, nothing to lubricate. It's a good system, but usually only on vessels with 4 chain lockers. On the right side, this is not in our fleet, but we see the cable lifter, and on this vessel it has 2 hydraulic chain pullers to be able to get the chain to the lockers. So I did a check on Westshore the other day, and I think about 70% of the spot fleet today have chain chutes, and the remaining 30 has a combination or chain pullers. So there's a big difference there. And if you need to run chain chutes is the preferable option. That's my opinion, of course. So here we see this is a semi-handling system where we have the chain puller at the top and we have the chutes to the lockers. And again, 76, 165. And often we looping the chain between the lockers. And that's okay for 76, 84, 120. But when we get up in 165, we see that our rail cranes are too weak. We don't have the capacity. So it's often a good idea to have some extended crane capacity. So for a clean anchor handler with only rail cranes, it gets complicated to loop the chain between the lockers. This is my favorite vessel, not mentioning names, but this is 160 chain. We don't have any chain pullers, and we see here we still have room in the chutes. So they are at least designed for 160 to 165. What we have experienced with running these big chains is we need to reduce the speed. There's a lot of wear and tear, vibrations, and when we reduce the speed, the chain climb more. That is something we see on a general basis also for larger dimensions. So the typically 80% filling rate we often provide as a capacity, that has to be lower when we see these dimensions. The chain pullers, on the active chain handling system, a lot of vessels has these. Here we see one of our vessels at a yard stay, obviously to the left before and to the right after. And what a lot of operators and vessel owners forget to do when we are signing a job for increased chain. You see on the left there we have the bars on the chain puller. They are supposed to be adjusted in diameter. Most of the anchor handlers today have a set position of this, so we can run 76, 84, 120. But if we need to run 160, we need to increase the diameter. So all these bars needs to be bolted off and shifted to a more outer position. And that is a long, and if you have the scenario to the left there, it takes days to actually to do that modification. On this vessel, if we increase the diameter on the bars, we will get clearance issues with the roller we see above. So that is specific for this vessel. There's always something when we try to increase the diameter. Typically for floating wind, if we need to do, well, let's see if it happens, but 20, 30, 40 trips of pre-installation, when we need to haul the chain from the mobilization base to the field, we are proposing as an improvement to have the operators purchasing a forerunner chain. A lot of the vessels today already have 76 and 84 forerunners in the bottom of the chain lockers. But one of the most risky operations we have when running large chain is to get the end from the mobilization key over the cable lifter and to the lockers. So if we can keep an inner length during the entire operations over several trips, this is something we strongly recommend. The operator will also save time if we have a long operation. So I'm mostly focused on the chain. I think the chain is the key. But of course, we see, especially in floating wind, the polyester, the diameter is increasing. The lengths are what they are, but our winches could be too small for what we see coming up in the floating wind. We see diameters of 250, 260, 280. Potentially inland buoys are getting bigger. They need to be handled by the rail cranes. So we have a rail crane issue when we get up to these dimensions. To the right there, we see an inline tensioner on a mud mat. This is a design I like. Can we pull it? We will get it to work. If we need to lift it in place, we will have problems with the clean anchor handlers only with rail cranes today. So, design it to be pulled on deck. That's one of our recommendations. I want to finish with 2 slides, a completely different topic, a little bit environmental and technology update. We are part of a group, a project called Nemo Ship. There's a lot of companies involved in that project. But actually today in Stavanger, we have had dry docked this vessel and we have installed a battery of 1.1 megawatt. And this is the first time we have combining 2 types of battery in a battery installation. It's a little bit difficult to see, but we're also installing the batteries in a tank below deck. So we are not putting up a container solution on deck. In addition, we are installing SCR units in the funnels. These vessels were not delivered with SCR units, so there will be a significantly reduction once these are installed. Also, we are installing propeller caps on both main propellers and also a subsea crane, 20 ton. So, what are the benefits of this? I think the bollard pull is the most interesting here. This is a vessel with 339 tons today. We lack some electricity on the circuit, so we need to do a bollard pull test first, of course, but we will have more power available for the azimuths. So we will see an increase in the bollard pull of this vessel. The SCRs will reduce the NOx. This vessel had not NOx SCRs units before. Here you see the funnels, and it's quite a huge job to install these scrubbers. The propeller cap will give us an 2 to 5% of annual saving in transit mode. And of course, the battery will give us a lot of savings on the fuel, and but we hope to present the as-built data on this later. The vessel needs to get out of the dock, I believe, next week, and we need to start the testing. So that's what I had today, but remember, a chain link cannot be larger than its handling equipment.